Cool. All right. I just want to go over the answers to this third question on the mock. I'm working a bit backwards because I'm mindful that you guys asked me to look at these thermochemistry questions first for the structure and bonding. So for that first one, we are just looking at could you identify endothermic and exothermic reactions? First one is endothermic, second one's endothermic, third one is exothermic. Being able to identify 2 out of the 3 was your first achieved point, but if you wanted to get merit, you needed to give me your reason why. So for that first one, it's because your delta H is negative. No, your delta H is positive. Sorry, there's a little typo on there. Let me fix that. So you should have seen a positive number there, and that's why you knew automatically looking at it. It is endothermic. The second one was about dissolving ammonium nitrate, and it makes the water cooler. So that means it's absorbing heat energy, so that's why that one's endothermic. And then the next one is you look at that diagram there, and you see that the reactants have more than the products when it comes to energy. Let me just go back here. So we see that this has more energy than what C does, and it means it has been released into the environment, and so that one's exothermic. So nice, easy, kind of start off with those thermochemistry questions. That's all you really needed to do for that first one, and you could get all the way up to a merit point. But for that merit point, you need to have justifications for all 3 of those reactions. If you made a mistake on one of them, or you didn't have a justification for one of them, you would only be getting the achieved point. Are we okay with that so far? All right, second one here was a calculation step. Do you guys want me to do the math and actually step by step show you the answer? I see some head nodding. All right. I'm just looking at what we have for our 2 questions. I'm checking our time. We should be hopefully okay. All right, so we want question B. How do we do that math? So let me walk you through it. Personally, what I like to do with these is I like to answer them to the excellence level and then show you where the achieved and merit points would have been or where the mistakes were. The reason why is because that's usually the instance of how these mistakes occur. In this case here, you had 2 calculations for part B. If you got both of these correct, that was the excellence point. Getting half of it then was your merit points. So what I'll do is I'll do this in blue pen, which is my merit color, and then I'll show you where the other points are. So in this question here, we have an equation for a thermo decomposition of mercury oxide. They've given me that equation. So here's my mercury oxide. It's becoming mercury and oxygen gas, and they've given me the enthalpy value. I can tell from this that's a positive number, so that's going to be endothermic. It's really useful just to annotate the question as you're going, so that way you're pulling the information correctly. I've been given the molar mass of the mercury. I've given the molar mass of mercury oxide. They haven't given me the molar mass of the oxygen gas, and I'm guessing it's because you don't need it, so that's why. They want you to calculate the energy needed to decompose 277 grams of mercury oxide. Again, I'm underlining everything so that way it's easy for me to pull that information out. With this question here, there are 2 steps to that process. The first step is my conversion, and then my second step is using the energy to figure out, okay, how much is actually produced. So the second part would be using this bit here. All right. So first thing I want to do is I want to make sure I do that conversion. So this is in mass, and I need this in moles. So if we remember, moles equals mass divided by the molar mass. So when I do that calculation, I'm going to take the 277 grams. Really useful to write your units, so that way you can check it cancels out. And then I want to divide it by the molar mass. In this case, because we're asking for the mercury oxide, I'm using the 270, and I want to do grams per mole. By doing grams per mole, I know that the grams cancel out. I see that I have per mole, so I know I've set up my calculation correctly. That's why it's so good to put down your units. I would also recommend you do that in physics, so that way you don't accidentally make a silly mistake. All right, so my mole value is 1.276. I'm just going to do dot, 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 but I'm going to use the unrounded number in my actual calculation because the rounding could slightly change my answer. Are you okay with that so far? And that's now my moles. Cool. Second step then is I need to figure out how much energy that amount of moles is going to give me, and I'm checking my ratios. We're thinking stoichiometry right now. So this is 128 kilojoules, and that is in reference to 2 moles of my mercury oxide. So be mindful that when we're saying kilojoules per mole, we're saying that per reaction. So I need to factor in that there's 2 moles of this. So what I'm doing is I'm dividing that by 2, so that cancels out. So then I now know that for 1 mole of mercury oxide, it's 91 kilojoules per 1 mole of the mercury oxide. Are we okay with that so far? All right, so now when I want to figure out the energy release, all I'm going to do is take this number and multiply it by the moles. So 91 kilojoules per mole times the 1.276 number that I got. And from there, I'll be able to figure out what the energy is. So 1.276497696 times 91, and I get 116.16. Now, again, we want 3 significant figures, so we're going to do 116 kilojoules is how much energy is going to be released. Are we good with that? All right. Calculating that correctly, but you don't need the significant figures. That would have been one of your merit points for that. Are we good? All right, next question. All right, this one here is kind of flipping the story. So we are asking how many grams of the mercury is formed when I absorb 155 kilojoules of energy. So it's basically the similar calculation, but we're working in reverse because we're trying to then figure out, okay, the moles for my mercury. So what I want to do is convert this into moles so I know how many moles of mercury is produced. So when I look at this ratio, again, we have for every 2 moles of mercury produced, that's how much energy it's going to take. So 2 moles of mercury is going to be equal to 182 kilojoules. So I need to then divide both sides by 2. So for every 1 mole of mercury, oops, that should be in blue, produced, I need to use 91 kilojoules of energy for that. Are we okay with that so far? All right, check your ratios, do some stoichiometry. So I have 555 kilojoules divided by 91 kilojoules per mole. Are we okay with that? Kilojoules cancel out, and what that tells me is how many moles that I need. 555 divided by 91 equals 6.0989 ... moles. Are we good with that so far? Cool. All right, next thing then is I need to figure out the mass. So if I know that moles equals mass times molecular mass, mass is equal to moles times molar mass. So I'm going to take that number, that's 6.09 ... moles, and I'm going to times it by the molecular mass of my mercury. Surprise, surprise, they've given me that one as well. So that's 201 grams per mole. Again, check your units. The moles cancel out. I am on the right track. So I take that number, I times it by 201, and I get my mass equals to 225.87. Again, we want to change it to 3 significant figures. So 123. So I do 1230 grams to my 3 significant figures. Are we good with that so far? All right. Getting the number again is going to be your merit point. For the excellence, you need to get both of them with the significant figures and your units. That's the only way you get your E point. Really easy E point if you know how to do math. All right. For the achieve, lots of different ways you could have gotten that. The first way you could have gotten the achieve point is that you correctly converted this into moles. So here was your A point. The other A point was the amount of the moles of mercury. So this here. So basically, if you could do the first step of the calculation, you got an achieve point. If you could do both steps, you got the merit point. If you could do both versions, you got your excellence point, so long as you remembered your different things. Are we good so far with that? All right. I might then go back to the answer key to save us some time, because I know the bell's going to go soon. So we're just going to do a combination of things, but I figured you guys needed the math. All right, for question number C, you had to draw one of these guys. If you're not sure what to do, guess what they had in the first part of question A? One of those diagrams. So hopefully from that diagram, it was a good hint of what you're supposed to be doing. So in this case, you have been given an exothermic reaction because it says that it gives out heat energy. Well, hint, hint. The first one in part A was an exothermic reaction, so you literally could just copy what you had they have given you into that and get yourself a point. So drawing that diagram correctly was an achieve point. Correct sign for your delta H, which is going to be negative, would have been another achieve point. Really easy 2 points there. For the merit, you needed to justify your reaction, explain a reaction. So correct reaction profile, correct sign, correct justification. It's exothermic because it's releasing energy. This one, oddly enough, was also an excellence point. I thought that was quite generous. But in this case, you need to explain. So you had to link it. Exothermic because of that negative enthalpy value, energy is being released. The overall system's releasing the energy. The thing that is going to be important, though, to get that excellence point is understanding the bonds. So there's more there's more energy being released from the bond formation than what was absorbed to break the bonds. Remember, absorbing heat energy to break bonds, and then making bonds release this energy. So we're looking at the comparison between what needed to be absorbed to break everything versus what is released. Since it's released so much energy, those products would now have less energy stored in their bonds. Does that make sense to everybody? All right, cool. Oh, we finished a little bit earlier. That's fine. All right, so go ahead and keep working. I do want my little baggies of highlighters in there. Make sure that you have a red pen in there as well. I should have given you a new red pen in there. Hand in those CPR quizzes and hand in any work that you've completed during this hour so that way I can start collecting data. Cool? I guess we finished a little bit early. That's fine.